Thank you. Okay. We got the. Can we get the slide up there? I'm going to start by saying, okay, I'm Simon. Once we get the presentation up, okay. Well, I can start by telling you, okay, with the name of the segment here is Audio Artistry. I'm actually going to talk about audio quality and how that's really about why you should care about it or not. I'm getting distracted by that a little bit, I guess. I'm going to start by, I'm going to start by introducing myself. I'm sorry, here as we go. Let's see. Here we go, okay. So who the hell is this short guy with the red pants standing in front of you? I have a company called Desonic. We have been doing audio for games now for about 12 years. We've worked on over 100 titles. It's actually, we really lost count at about 100. And those range from console games to iOS titles. There have been, big hit things like BioShock series and Spec Ops: The Line. And all the way down to, I shouldn't say down to, but including indie iOS apps and all that sort of stuff. I figure kind of probably the best way of giving myself some credibility here is actually play, this is really a reel of what our company Desonic has done. Okay, there's a bunch of stuff in there that was console games and so forth. It's not all iOS stuff. However, when it comes to audio, there's these things are pretty. What makes good quality audio in one case is pretty much the same across the board there. The other thing I should just mention is I'm going to show some more examples as I go here, and these are all things actually that we've worked on. Primary reason for that is that putting together these game capture videos is it kind of takes a bit of work, so it was sort of made it doable for me to use stuff that I already knew and we had on video. So all of the examples you see are going to be from us. So I want to deal with this question of audio quality. And start by asking the question of, why should you really care? And when it comes to developing games, and I will have to say that I'm going to be talking primarily about games, but I believe there's there should be some stuff that applies across all kinds of apps. So when it comes to doing games, anyway, I know for a fact that the most time and effort that you guys spend is on the graphics, the programming, and the gameplay. that they take up most of your time when people review games. It's probably most of the things they're talking about is related to those things. So audio is sort of not really getting a look in here, and so I think we've got a legitimate question to ask, which is why do we how much effort should you really put into this? So I'm going to kick off here with a quote from this guy Scott Hansen. He was a lead game designer at a company called Mumbo Jumbo. They made a series of games, a franchise of them really called Luxor. They started off with a small team. He was the only game designer there, and he really hit it out of the park with that because they were with the revenue from this one game. They were able to the series of games really. They were able to go buy other companies with it. So he said, as it says up there, focus groups have proven that the same game played with substandard audio gets poorer marks overall. So he's really, I'm using that because he's really making a big part of the point for me. But we're not going to take his word for it. What I want to do is sort of delve into it a little bit deeper and talk about, okay, what actually do we mean by audio quality? And if you talk to audio guys, and I have to admit I'm an audio guy, about quality, you're going to get people talking about things like, fancy microphones and mixing consoles, all this gear, perhaps bit depth and sample rate and all that sort of stuff. And all of those things are well and good, and they're sort of tools of the trade and everything, and you can get very excited if you're an audio guy about, this gear giving you that last, 5 or 10% of sort of quality on the actual, recorded audio that you're using. But I don't think that in this sort of an interactive environment that you have with an app, that's really a good definition for audio quality. So we're not going to talk about that stuff in terms of audio quality, and we're going to redefine our definition of audio quality to being the extent to which the audio improves the player's experience. So the extent to which you're improving the player's experience using the audio, and that's our new definition for quality. So with that in mind, I've got another video clip here. I suppose it's worth turning the lights down again. What we're going to do is there's two parts to this thing. There's two games in there. One's a casual game, one's from a console game. But while it's playing, just think about what the sound effects are doing to give feedback to the user about what they've just done, and to reward the user for sort of the moment-to-moment things that happen in the game. Okay, actually, perhaps let's see if I can do this with the lights down. We'll just leave the lights out for a minute. So let's have a look at, this is kind of an age-old trick, but I'm just going to mute the sound here and have a look at just the beginning part of this again. So as this is playing, without the sound, and the graphics are still there and they're doing what they're doing, but once we reintroduce the sound, notice how much impact it seems to get back to the graphics. So the sound is playing a part in this case, not just to add sound to stuff, but it's actually making the graphics look better. And I think that, getting back to that Scott Hansen's quote from earlier, that's the reason that the game gets poorer marks if you don't have good audio, is because the users are reacting to the graphics and everything else because of the audio, at least in part anyway. Could we have the lights back on again, please? So let's see, where's my clicker here? Let's see if we can move on from this. Okay, so I want to take a little look at what makes the sound effects work. So I want to talk about the high quality sound design, designing high quality sound effects. It's about, and the deal here is that if you get these sound effects tightly synchronized with the visuals, that's kind of a key part of making the sound seem as if it's actually being generated by the visuals. And so a quick sort of flip side of this is, so one way of saving money when you're developing a game or an app or anything is to use downloaded sounds. And one of the main things that you're not going to get if you download sounds is that they're not going to be tightly synchronized to whatever your particular visuals are. So here, let's see whether I'm asking you to turn off and on the lights all the time. Maybe we can just watch. This is kind of a white backdrop, so we could just leave the lights up for this perhaps. And I'm going to stop and start this too. So what I'm doing here is going to show you an example of some sounds where it's not tightly tied to the visuals, and then one where it is. So here we go. Let's play the beginning of this. Okay, so now just to look at that, what's happening is when the dog is at the peak of its animation, it's sort of after the peak of the sound sort of thing, and when he snaps his jaw, kind of nothing is happening. So I'm just going to show that to you again so you can take another look at that. Okay, then here's a tight. So you can see in that one that, I'll just grab that guy again, that, like when the jaw snaps shut, you can hear a nice satisfying chunk sound there. And it all sounds like the animal's actually making that sound. Okay, next one here. Let's get that. So in this, notice how when these bits of wood fall down, especially, there's a bunch of wood that hits the ground and there's no sound. Like that very loud. Now, when we put it together, that last, especially you can sort of notice that last chunk of wood hitting the ground kind of thing. Oh, let's stop that. So that's the difference. It's making the sound appear as if the visuals really made that sound, and it's not something that people are going to kind of consciously notice, but that's the reason that it makes the visuals actually seem better. So, a little word about budget. One of the things you want to do when you're budget's always an issue when you're making games, when you're making apps and that sort of thing. So for a start, now I dissed the downloaded sounds before, but actually you can use those things when you have visuals that are not moving. So they're not animated, or you're not got a particle effect or something like that. So if you have like just a mouse click, or if you've got, say, a dialog box that's popping up and it's there's no animation to that, it's just showing up, then you don't really have any movement to synchronize to, and so you can use the downloaded sounds in that case. Then, taking whatever money you have, you want to sort of prioritize the frequently heard sounds. I think that's probably fairly obvious. And the other thing is to prioritize sounds that are rewarding the player. So, you're probably putting effort into the graphics there anyway. So, if you can also, beef that up with sound effects, that's going to be, it's one of the reasons your player is playing the game. Aha, I just did that kind of thing. And just another word on sort of relating to the budget, because the high quality sound effects can sort of give that effect of making the visuals look better, then you might consider that it's actually sort of a cheap way of improving the graphics. Like working on the getting audio done is cheaper generally. It takes less time than working on graphics. So you're actually sort of saving money if you look at it in that regard. Okay, so that was the sound effects side of the picture. Now for the next part, I want to talk about music. And we're in UCSF here, and I'm probably going to get myself in trouble, but I'm going to go out on a limb, and I'm going to involve a little bit of brain science here. And actually, Tim said when we're giving these presentations, give people things to read. So here's a great book to read. This is called On Intelligence by Jeff Hawkins. He lays out a sort of an idea about how the brain works. I'm going to borrow some ideas from this, and but it's massively simplified. But anybody who's into AI or anything like this might be interested in reading this book too. Okay, so we can think of the brain as having some layers to it, and sort of you have these unconscious processes which are dealing with all the inputs coming in all the time. I mean, there's constantly data essentially coming in through our eyes and our ears especially, and all our other senses, but our unconscious processes just handle that. Without us having to consciously bother about it, until something comes along that is sort of perhaps unexpected. And so we're about music here. So if you've got a melody popping into it, then the unconscious processes send a message up to sort of the upper layers and eventually to our conscious layer and sort of say, okay, hey, this is new or different. Pay attention to this thing. What happens when you've got a game and you have melodic music playing? Now, melodic music, music with a melody, composers learn to write this stuff. We learn to write this stuff so that it has sort of internal repetition, and it has repetition in the structure, and it's varying that, and there's all these little tricks we do, which are really about making that melody catchy. And that's great if you're going to, if you're trying to write a top 40 hit. But when it comes to a game, when it's designed to grab your attention, these melodies, that actually can distract from the gameplay. So what happens is that the users turn the music off. Who would blame them? So it kind of what happens here, it's kind of similar to, say you're driving along somewhere, most of the route, you've got the music playing, you drive along, but then you come to the end of the journey somewhere there, and you've got to find a turn-off you haven't taken before, or maybe you're looking for a street number or something like that. The first thing you do is you turn the music off, or at least way down, because the music's trying to grab your attention, and you go, no, I've got to focus on that street number kind of thing. So you have to, reduce it down to just one thing. And that's exactly the same thing that's happening in the game. The game players, they want to play your game or use your app. That's the thing that they're there to do. So they don't want to be distracted from that with this other melody thing. And for anybody who's shipped a game, I mean, you have to ship the game with that button that turns the music off. It's just kind of like you just have to. Okay, hello. We've got I've got two solutions for this. So the first one is to actually remove the melody. Now, if you remove the melody, what you're left with is this underlying groove, which sets mood, and that's what music is all about. It's about setting sort of the emotional content, but it doesn't have that particularly distracting melody element to it. I have, just to sort of demonstrate what I mean by this, I've got two clips here, just audio clips. They are one with the theme and then one with it removed, so you can kind of hear what I'm talking about. Let's see, is it going to play by itself, or am I going to have to click it? Here we go. Okay, so that's our theme. I don't know if anybody noticed, it take me a little time, but there was a lot of internal repetition in that theme just there. Oops, okay, so here's the same thing with the music without the melody. So that was actually, the second one was kind of like more boring than the first one, right? I mean, we're all sitting here listening to it, but it doesn't have a melody to it. And but actually, the fact that it is more boring is exactly the reason that it's more suitable for playing while you have gameplay or something else that the user's trying to concentrate on. However, it's still got the sort of a rhythmic element to it, so it can convey energy or something. So if you've got a battle scene going on. Okay, so solution number 2, just back to our little diagram there. Remember, we've got the unconscious processes getting interrupted by the melody and pinging that up to the conscious awareness. So in this case, we're going to use ambience to completely get rid of that step there. So the unconscious processes are just handling it when we're using ambience. Now, ambience is a little bit like the background noise in this room. So if I was to just shut up for a second and just have a listen to the noise in the room. So you might notice, if you're paying attention, there's a bunch of fan noises, or at least that's what I can hear up here. There's various things with fans in them around the place, and that's been there all the time, and our ears have been listening to it. But because it's a steady thing that's not changing, our conscious mind is not processing it all the time. Thank God, otherwise we'd be distracted by it. So ambience can do the same thing. And the type of ambience I'm talking about, and it can set a mood, but it becomes subconscious. So I'll play some examples of that so you can see what I mean by this kind of ambience in a game. We could probably do with the lights down for this one, I think, too, please. Let's have a look. You got to love violent video games. So you can sort of see there that it can set some different kinds of moods. It's not good if you need to have energy and action in it, but in many other cases it can be very useful. So finally here, I just want to get back to melody. I've been dissing melody all of this time, but I don't mean to say that we shouldn't have melody in games. It's just that it's much more powerful when it's used sparingly. So one thing that I often recommend to our clients, actually, when we're doing iOS games, is a way to use melody is you have in the menu a theme. So when you first jump into the game, I mean, this is fairly typical. You have a theme. This doesn't need to be very long, but it's the melodic thing, and you can have it be like 30 seconds or so. And then when you say win or lose a level, so this is sort of about rewarding the player if they win, or not rewarding them, I guess, if they lose, you have a short musical sting that comes at the end there. That can be related to the theme, so like a triumphant version if you win and a not so triumphant one if you lose. And then while they're actually playing the game, use ambience or or the musical grooves that I've talked about for in the game. Now, by doing that, there's actually a bonus to this whole situation. I'm assuming everybody probably is familiar with this cost, time, quality triangle. You know, if you, for example, try to ship your game faster or your app faster, it's going to cost more and the qualities go down. You know, by improving one of these things, you decrease the other two. However, in this particular case, we actually get to reduce the cost because the ambience and those musical grooves, they're not as time consuming basically to create as fully composed music. So you actually save money there, and at the same time you're improving the player experience, right? You're allowing the player to focus on the game while they're actually playing the game, and you're giving them the theme when they're not. So you're improving the player experience, which was our definition of audio quality. So you've done both of these two things simultaneously. I don't know of any other case where that's the case. So savor that. Landing back to our initial question of why should you care? Well, what we did was we were totally synchronizing the sound effects to the visuals to make the visuals look better. And then we're using ambiences and musical grooves so that you don't distract the player from actually playing the game. And all of that is adding up to a better experience for the players. So there we go. That's what audio quality can actually do for you. I'm going to wrap up now. Here's my contact information. If anybody, I'll be very happy to hear from any and all of you. And so I guess my part of this has been to talk about I'm Simon, I'm talking about the art. And next we have Art, who's going to talk about the science of the whole thing. Thank you. Oh, and we're going to do a little bit of a hot swap here of laptops. By the way, I was afraid to ask this before I started because I couldn't really change my talk. But how many of you here are actually developing games? Okay, reasonably, and the rest of you didn't really care too much, perhaps. I don't know. Okay. Plenty of time. And you're off.
All right, awesome. So good morning. Oh, seriously, how many of you are there? Good morning. Everybody hates the guy that goes right before lunch. I don't know about you guys, I'm starving. So we're going to go through this really fast. My name is Art Gillespie. I'm a media engineer, and I specialize in iOS. I have a bunch of slides here about how I came to be an iOS developer, but we're running low on time, and I really want to get you to lunch on time, so this is going to go really fast. I released an app called iDrone. It was a plugin for GarageBand 1.0. It was really successful. Apple liked it so much, they put it in their retail stores. Everybody made a lot of money. March 2008, the iPhone SDK was announced. I sent a frantic email to my friends on the core audio team at Apple asking what we were going to get before the SDK was available for download. And I'll never forget, Bill Stewart sent me an email back saying, well, it's pretty much what you get on OS 10, which was mind-blowing. I was expecting like a really stupid, play one audio file at a time black box. So we were able to do everything that we could do on the desktop on a phone. So we put a drum machine on your phone, and we shipped this the day the App Store opened. It's really successful, and over the next few years, we did about 20 editions of this with a ton of big artists like Depeche Mode, Underworld, and so on. But really, this is what I'm all about. I like to create things that help people create, and that's why I'm here today, really. It's my hope that I can, in some small way, help you guys create an extraordinary audio experience in your app. Was that short enough? So the moderator, Tim, chose the name of the talk, which is great. But if you'll indulge me one little edit. Today we're going to be talking about incredibly powerful software that's already in iOS for you to make audio apps. I'm going to come over here because I feel like you guys have been neglected a little bit. All right. Audio units. Let's look at the documentation definition. Audio units are a set of application programming interface services provided by the operating system to generate, process, receive, or otherwise manipulate streams of audio in near real time with minimal latency. Everybody's really fired up to write audio apps now, right? Awesome. I like to think about audio units as the devices in my music production studio. And each unit is like a device in my studio. So I might have a DAC that goes out to my speakers. I have a microphone which serves as input. I have a mixer where all my sounds come together. I might have an EQ on each channel of the mixer. I might have outboard EQ. And the thing to keep in mind about audio hardware is it's all standardized. All audio hardware has input jacks and output jacks, and typically knobs on the front so that you can change the sound in real time. Like you hear these DJ sets. So audio units are the same way. They have standardized inputs and outputs. They have parameters that you can tweak in real time with code or in response to user input or in response to input from a Bluetooth sensor. So what audio units are available? If we, Tim said, give you guys something to read. So if we read the fine manual, Tim also said not to swear. So if we read the fine manual, we go to developer.apple.com, because that's what you do when you want to learn about iOS. Here's a list of available. No, really. Why are you laughing? That's exactly what you should do. Okay. This is a list of the audio units that are available on iOS. There's a converter unit, which lets you convert between sample rates. It's kind of boring. iPod EQ unit, we kind of talked about that. A couple of different mixer units, and 3 different input-output units. Anybody feeling inspired yet? You think you can make an awesome audio app with these 4 audio units? You can't. And our mistake here was that we RTFM'd. If you've been programming core audio for a while, like I have, since OS 10.0, you learn really fast, all us graybeards know, that what you really want to do is RTF-HF, which is read the fine header files. All the documentation, I got to say something nice about the core audio team here. They're really, really smart people. They're attractive, and they smell nice. Their documentation, not so much. I don't know why that is. It's always been that way. It's been that way for like 12 years. But the header files are awesome. They're really well documented. So if you want to do this kind of programming, just forget about developer.apple.com and go straight to the header files. And this brings me to a little aside. All these APIs are C. There is no Objective-C to be found. They're not hard to use. They're pretty straightforward C APIs, but they are C. So if you're coming from Objective-C or your C is rusty, I highly recommend Bill Dudney's fine book, All the C You Need to Know. Right, always suck up to the event organizer. So let's go back to our header file. The header file that tells you what audio units are available in iOS is in the audio unit framework. aucomponent.h is the name of the header file. And so before, when we looked on developer.apple.com, we had 4 audio units. If we look in the header file, we have 25, and I didn't even put them all up here. It was getting kind of cluttered, and I was really kind of paranoid about going after a typography guy. So now our kind of crappy studio that built into iOS that can't really do much is looking less like this, Bluetooth, and more like this, a fully appointed recording studio built into iOS, ready for you to sort of lash together into your apps. So we're going to talk about a couple of the highlights, the really important audio units, and we're going to do it really, really fast. The remote I/O unit is kind of like, if you guys, everybody knows UIKit, right? Remote I/O unit is like UIKit except for your audio. In the same way that UIKit gives you touches when the user touches the screen, remote I/O unit gives you samples from the microphone on the device. In the same way that you can send pixels to the screen using UIKit, remote I/O unit gives you the ability to send samples to the speaker. So this basically gives you the ability to get audio from the user and send audio to the user. The mixer unit is really straightforward. You'll notice, too, that I'm giving you header files where you can look all this up because there are no URLs. The mixer unit lets you create an arbitrary number of channels through which to send sound, and we'll get to how you generate sound in a minute. And then for each channel, you can manipulate the volume and the pan. And you need this because the remote I/O unit can only take a stereo pair of inputs. So if you want to connect more audio units to it, you need a mixer in between it, which sums all the audio up and sends it to the remote I/O unit. And this is the best thing in iOS, period. Audio file player unit. This is the most amazing piece of code that's included in the OS, and I'll show you why in a minute. But this lets you play back any file or audio format supported by iOS. You can seamlessly loop any file or audio format, and anybody who's tried to loop MP3s might have run into trouble with that. If the MP3 is encoded correctly, you don't have to post-produce it and do gapless. If it's encoded correctly, or the AAC is encoded correctly, this unit will automatically loop the full file correctly, or on the next bullet, you can see that you can do sample accurate subregions. This is really cool if you were doing a game and the player is maybe, like me, kind of not very good at games, is spending maybe a little more time than you expected in a certain region. You can actually just grab a loop of the audio for that area and just sit there and loop it until the user input, the player moves out of the way, and you can just play the rest of the file. It's incredibly powerful. The other thing that's important about this is sample accurate scheduling. Now, I know somebody out there is going, dude, why don't we just use AV Audio Player? And AV Audio Player is great, and it's really simple, but you can't schedule. If you invoke an AV Audio Player in response to a user touching the screen, it's going to play whenever it wants. If you invoke an AV File Player unit when the user touches the screen, it's going to play exactly when you tell it to, down to 1/44,000th of a second. Furthermore, a single AV File Player unit can play back a playlist of audio, looping each one as many times as you tell it to, subregions, everything you can do with it, but now you can have a playlist. And if you think about that, that's really like an audio track and an audio editor. Audio File Player unit gives you all of that. And furthermore, this is really amazing. Multiple instances automatically coordinate their streaming. It's a very low memory usage. It only takes up as much of the file as it needs to get audio to the output. So instead of loading the whole file into memory, this streams the files, and more importantly, it doesn't do stupid things like creating its own streaming server for each unit. It coordinates between them so you don't have weird disk I/O things killing your frame rate. So let's talk about a simple audio engine that you could build with this stuff. And all this is built in. You instantiate a remote I/O to give you access to the device's output. You instantiate a mixer and tell it you want 4 channels. And this kind of speaks to Simon's talk. So maybe you instantiate 4 file players, one with your ambient bed or your music bed looping, another one with your footstep sounds or some kind of ambient Foley, another one for FX that might be incidental like thunder or rain. And this takes about 100 lines of code to set up. But this is where it gets interesting. Let's say you want to, going back to Simon's talk, you want to separate the kind of rhythmic part of the music and the melody part, but you may want to bring that in dynamically based on user input, where you could create 2 file players, sync them, it's trivial to sync them, and mix that in using the mixer unit when it's appropriate. Furthermore, let's say we want the footsteps to sound like they're getting further away or coming closer. We can just instantiate a reverb audio unit, which is included with iOS. And then we can actually change the parameter of that reverb unit as the user moves around the world or whatever your app might be doing. I use that animation when this slide loaded intentionally, because you can actually do everything that we just did, add another file player, stick a reverb in between that file player and the mixer. You can do that on the fly without interrupting the audio. That's incredibly powerful. So you can actually have a sort of self-configuring audio engine that responds to user input, time of day. Sky's the limit. And what makes that possible is a technology that isn't an audio unit. It's called AU Graph, and you can find it in the Audio Toolbox framework. AU Graph lets you connect audio units together on the fly. It lets you insert and remove audio units without stopping the audio. It's a pretty simple API, but it's incredibly powerful. And this audio unit is amazing. How many people here have played with GarageBand? So you're familiar with instrument tracks? So you can like pull up a piano and play the piano. So you can take the instruments from GarageBand or Logic. In Logic, they're called EXS instruments. You can take the instrument and the samples that make up that instrument. You can put them into your app bundle. You can instantiate this audio unit, read in that instrument file, and you'll have access to that instrument in your app on the fly. It's a full-blown sample playback instrument. Like I said, it supports GarageBand and Logic ESS file. It's insanely CPU efficient. And if you have longer samples in your patch, it'll stream them. This is incredible. I actually can't believe this. This is really basically having the full GarageBand sampler in your app if you want it. So the way a sampler works is typically you give it one audio file, and it stretches that sound across the keyboard. So if you were to hit F1 on your keyboard, you would hear this sample play back. But if you were to hit A1, the sampler would on the fly resample it to A1. And that's cool. That's cool for things like pianos, synths, whatever. But another thing, I'm sure you've all loaded up the drum kits in GarageBand because that's really the most fun. You put a different sample on each key, and instead of it stretching, now if you hit F1, you get the kick, hit G1, you get the snare. And if you think about it, if you're designing an audio engine for an app or a game, it's really a short jump from this to putting all your FX into a note. So load all your FX into an AU sampler, and your audio engine goes from looking like this to looking like this. You can load all your FX into an AU sampler. Whenever you want to trigger it, you just call music device start note with the correct note for the effect you want to trigger. And the great thing is AU Sampler will take care of spinning up the file reading for you. You don't have to manage the file players on the fly. Again, incredibly powerful. I was kind of dumbfounded when they added it to the SDK. Finally, yeah, you guys are going to get to go to lunch. Finally, another amazing piece of technology that's built into iOS is the music player. And the music player is basically, again, to use GarageBand as an analogy, it's basically the Midi tracks for music player. So a music player has a music sequence, and the sequence is made up of tracks. And the tracks have events that are specified in musical time rather than in clock time or wall time. So and the most common events are sort of note on and note off, like here, typical Midi. But it could be anything. It could be parameter automation or any data that you decide that you want to happen at musically interesting times. So these tracks make up a sequence, and what's cool about this is you can actually loop tracks independently, mute and solo them, just like you can in GarageBand, but you can do all this programmatically. And furthermore, much like the AU sampler can load EXS instruments and GarageBand instruments, the music player can load, edit, and save standard MIDI files. So you could actually have your composer Simon hates this. You could actually have your composer or your sound designer do the music for your app or your game, and then just give you the samples, the instrument files, and the MIDI files, and you just load them into your app bundle and play them at runtime. This gives you incredible flexibility because you can take instruments in, you can take them out, you can add effects on the fly, you can change the tempo without having any kind of artifacts. It's incredible. So our MIDI-powered audio engine might look like, instead of using file players directly, we might just use AU samplers with different instruments in them and a music player triggering them. This is incredible that this is built into iOS. I'm shocked how many people don't know this. So really, what we've done in 15 minutes is we figure out how to build GarageBand for iOS. And you're like, sure, we did. But think about it. The input and output is covered by the remote I/O unit. This left pane over here is just a mixer. The instrument tracks are just music player tracks. And the instruments they're triggering are just AU sampler units. And audio tracks are covered by the audio file player audio unit. So you really could. I mean, if we could figure out how to do this with the built-in software, you have to write very little code to use these audio units. If you figure out how to do this in 15 minutes, think about what you could do with a week or a month. So I'm Art Gillespie. Go forth, have lunch, make cool apps. Thanks a lot.